Seismogram analysis. In this video, we're going to analyze an earthquake seismogram to learn about that earthquake. Let's get started. Here's an example of a seismogram. So imagine for a moment you're sitting at a seismometer, and somewhere on the planet an earthquake occurs. And your seismometer records the vibrations from that earthquake in the diagram you see here. Believe it or not, from this simple diagram, we can determine a lot of information about this particular earthquake. Today I'm going to show you how to find the P and S wave arrival times, the lag time, the distance to the epicenter, the P and S wave travel times, and the earthquake origin time. So let's get started. When we look at a seismogram, you'll notice two distinct points on the seismogram. The first one is when the vibrations first arrive. They tend to be smaller vibrations. And the second one happens sometime later on. They tend to be larger vibrations. Now what we need to be aware of is that the first vibrations are always going to reflect the arrival of the P waves. P waves, or primary waves, travel faster than S waves, and so they're always going to arrive to a seismogram first. So all I need to do is look at the arrival of the P wave and head down to my time scale and record the time that that P wave arrived. In this example, it's about 8:21. If you notice, there's another big jump in the earthquake vibrations as shown on the seismogram, and that reflects the arrival of the S wave. The S wave, or the secondary wave, travels slower than the P wave, and therefore it always arrives at least a little bit later on. In this case, it appears to have arrived at about 8:30. And so I'm going to record that in my table. The next thing we want to be able to calculate is what's called the lag time. The lag time is simply the difference between the arrival of the P wave and the arrival of the S wave. This is a really important number because it can help us to figure out other things like the epicenter distance. Just keep in mind that if the lag time is a smaller number, that means you're closer to the epicenter. But we'll talk more about that in a moment. First, let's calculate the lag time for this earthquake. To do this, we're going to take the arrival time for the S wave and subtract the arrival time for the P wave. So in our example, we're going to take 8:30 and subtract 8:21, giving us a lag time, or a difference in arrival time, of 9 minutes. We'll add that to our chart. Now, once we have that piece of information, we can do a little bit of work to figure out how far we are from the earthquake's epicenter, which you can imagine is a valuable piece of information. To do this, we have to keep in mind that we have a lag time of 9 minutes. And we're going to go and grab our P wave and S wave travel time chart found in our Earth Science reference tables. I'm going to quickly walk you through this process, which we call the wedge method. We're going to grab a piece of scrap paper and we're going to line it up with the vertical axis on the chart. And we're going to go ahead and mark off whatever our lag time is. In this example, our lag time is 9 minutes. And so you'll see I'll mark that 9 minutes right on the edge of the scrap paper. Now I'm going to wedge it in between the two curves until it fits perfectly. And when I get it lined up nice and straight up and down and touching the two curves, the P wave and the S wave curve, I know I'm in the right spot. And all I need to do is follow the edge of my scrap paper down to the bottom of the chart, like so, and that will reveal how far I am from the epicenter. In this case, it appears to be about 7,600 kilometers. We can add that to our table. So what I've just established is that when I have a lag time of 9 minutes, that means I'm 7,600 kilometers from the earthquake epicenter. Now once I've got this, I can tell some other interesting things, including the P wave and S wave travel time. Now here's what this means. This is going to tell me how many minutes a P wave or an S wave traveled from the earthquake to arrive to me. In other words, how long does it take a P wave to go 7,600 kilometers? So let's go back to our chart and let's find that distance that we just established, that 7,600, down on the bottom of the chart. And we'll go up from that until we hit the P curve. And once we hit that P curve, we'll head over to the left and we'll see that it takes a P wave about 11 minutes to travel 7,600 kilometers. So I'm going to add that to my chart. I can do the same thing for the S wave. Back to my travel time chart, back to my distance of 7,600, but this time I'm going to go all the way up to the S curve and over. And I see that my S travel time is going to be about 20 minutes. That's an important thing, because in order to find the time that the earthquake happened, also known as the origin time, I need to know the travel times. Now, there's actually two ways to calculate the origin time. We can do it using our P-wave data, or we can do it using our S-wave data. Now, if we did things properly, you should get the same answer both times. Here's how it works. I want to know what time on the clock that the earthquake actually occurred. So what I'm going to do is I'm going to look at my P-wave arrival time. This is the time that the P-wave got to my seismogram. I'm also going to look at the P-wave travel time, which is how long it traveled before getting to me. Now, if you think about this in terms of being something like, let's say, the pizza delivery man. If the pizza delivery man arrived at my house at 8:21 and it took him 11 minutes to get here, can't I figure out what time he left the pizza place? It's the same idea here. We're going to do a subtraction problem with the P arrival minus the P travel, something like this. The P wave arrived at 8:21 after traveling for 11 minutes, which means it left the earthquake at 8:10. So I know my origin time, or the time of the earthquake, was 8:10. Now, theoretically, if I do this with the S arrival and travel, I should get the same time. So let's say the soda man arrives at my house at 8:30 after traveling for 20 minutes. Let's do the subtraction. S arrival minus S travel is going to give me an origin time of 8:10. Notice it's the same as when I did it with the P waves. So I know that the earthquake happened at 8:10. And so that's all the information we can find by simply looking at this basic seismogram diagram. It's important to be able to find out all of this information and to comfortably use the chart in your earth science reference tables.